Betfair Romania Development. And next to me is my colleague Sorin.
Hello everyone, my name is Sorin Circo. I am a data engineer and petty power Betfair, and for today I am also glad to be here with you.
Okay, so today we are going to talk about how we use machine learning in Betfair, what are the different use cases, and two of our implementations that drive real business value to our company. So to start with, here is our agenda for today. We have four main key points, but make sure you keep an eye on the third one, which is the most interesting part. First of all, let's see who we are. Betfair Romania Development is our local company here in Cluj. We are known as a development center of excellence for data delivery, gaming, marketing, and customer management. We are part of the bigger group, which is Petty Power Betfair. Thanks. Petty Power Betfair, which is our European business. And Petty Power Betfair, along with the other brands you see here, is part of the newly formed global overall group, which is Flutter. Flutter Entertainment is a really huge company. We can see we have more than 8,000 employees and more than 1.9 billion pounds in revenue, which is quite impressive. Here in the here in this square we have two of our most powerful and most important brands that we look after, and I'm going to tell you a few words in a bit about each of them. So, Petty Power. Petty Power is our European brand, having a presence both in online and retail. And in retail, we have more than 600 physical shops, which is quite awesome. While Betfair is our global online brand, it is well known for our revolutionary platform, which is Exchange. Exchange allows our customers to bet against each other. Okay, I'm going to let Sorin to tell you more about our data and analytics department in the company.
Thanks. So, it is about Flutter, Petty Power Betfair, data and analytics department. In the few minutes ahead, when I will say we or us or ours, mainly it's about data and analytics department, which is located entirely here in Cluj-Napoca. Data and analytics estate. So I always had problems with English grammar, whether to use the word big or large. It's not clear for me which is good, but for sure huge is good. Both from grammar, English grammar point of view, and from the point of view of what contains our estate. It is represented here. So it's a huge estate. From our point of view, an important thing is that the entire it's about reflexes as well. That this entire estate is in our responsibility. That means data and analytics department here in Cluj. Well, obviously, it is about when I say huge, it is about the services we provide. It's about the capabilities we have, and also it's about the large variety of technologies. Most of them, almost all of them, state-of-the-art technologies that supports the services and the capabilities that we provide. All here are important, but I should stay with what's for us more important here on the right side. It is about our customers. It is about our data consumers, in fact. They can be physical persons, they are physical persons, from our Paddy Power Betfair company, from other companies inside Flutter Group, from other third parties. I guess, I'm a data engineer, so I can't be sure, that all departments in our Betfair company use our services. It's about commercial, it's about trading and risk, it's about legal, it's about, we even have a fraud department in our company. So basically it's not about what department we have, but it's about what kind of data, how various data we are managing. Also, there are other services, other processes that uses the data we provide. So basically we offer the data via, I guess, every imaginable channel. We deliver it by, I don't know, for physical person, of course, via different BI tools. The plural is because we have more tools for business intelligence. Well, we deliver it via, yes, direct querying the databases. We deliver it by APIs. We deliver it by SFTPs, servers. Even streaming, Kafka streaming, we have on the output. Well, the huge load on the right is balanced by a similar huge load on the left. On the left, we have the source data that enters our system. We talk about, several databases, different technologies, I mean SQL Server, SQL, Oracle. For database freaks, I say that this order is not by happening. Oracle is okay. And we also have events and data streaming on the output. We also have APIs or FSTPs. In between the two left and right sides, there are blocks that do data processing, that do data storage, basically a lot of work for us in between the left and right areas as well. And everything is under the cloak of a very rigorous, my subjective point of view, because I'm a developer, too rigorous, security and monitoring. Again, a lot of technologies involved in that area. From these blocks, the area of advanced analytics and modeling will be sliced and detailed in later slides. Well, previous slide was about technologies, was about services we provide. This slide is about figures. Over 1,000 users, over 1,000 users of BI tools. We have more than 400 direct users that access databases. We have more than 30 data sources. And we manage at about 400, only at about 400 tera of bytes. Relevant figures, but for me personally, the most relevant figures are these more than 3,000 ETL jobs that run daily, several times a day, and over 3 million queries inside databases per month. That is happening in our system. Well, again, from a subjective point of view, I say that right now machine learning consumes resources, so some of these figures comes from what machine learning is consuming, but for sure it's not among the most intensive consumers. But also for sure, I can say that it is on a growing slope what machine learning is consuming. And next slides will be about how is machine learning treated, considered in our company.
Thank you. So next we are going to talk about our setup of machine learning. And here is a picture that we took from an article we recently read. And what I like about it is that it places the ML code right in the middle, but at the same time, we can see that the ML code that we use to build ML models is just a tiny bit in the whole infrastructure needed to have an end result, which is predictions. So you can see we have data collection, feature extraction, checking, process management. So many complex processes surround this ML code. So as pipeline for our ML models, when we build our ML models, we base our approach on these three main steps. So the first one will be creating models, then productionizing, so putting the raw ML code, transforming it and putting it into production, and then monitoring and analyzing the results. So here is our pipeline. First of all, as I previously said, we have creating the models. So our data science team is responsible for creating the models. They start by finding the algorithm that best suits the business case. After that, there is a complex process of preparing data, pre-processing data, filtering, correcting, cleaning, aligning the data in order to best fit the structure that the algorithm expects to. Next, they do feature extraction. They experiment with different versions of the models, analyze the predictions in terms of performance and accuracy, and finally choose the final version that will be put into production. As technologies, we see here R, Python, SageMaker, many AWS services. In order to host the data, we use S3. From SageMaker, we use the Jupyter Notebook in order to experiment with everything that is needed to create a model. Okay.
Wow, thank you, Anca. So it's about 3 areas. Not 51, so it's not about area 51 here. But having into consideration the complexity that's happening behind these, I don't know, squares and whatever pictures here there are, I could say that we are talking about, I say, state-of-the-art, top of the science. Okay, from this point of view, it is something like Area 51. Okay. What's the output of the first area? It's a model. So basically, what was there done? There was decided the model, then it was trained, then it was tuned, then it was tested, then it was evaluated, and it is a lot of work here. And basically staying inside this area, somebody could say, okay, merely all the work is done. Because here's the model and it works. Here are the artifacts, because in fact the output is the artifacts of the models. Are the artifacts. Okay, but with just a slightly change of the perspective, and the slightly change is about thinking of the added value brought by that model to the company who invested in developing that model. When we take this perspective, we see that the work, in fact, the big work is just about to start. And so we enter in the second area, which is productionizing the model. What is this area about? Well, that model, the coding behind that model should work not in an isolated scientific-like environment, which is characteristic for the first area, but into a production environment, and the keyword here is automation. So basically that coding should work in an automated system. Also should work in an integrated system, because a model produces predictions that are used for something which is inside something bigger. So basically it's about integrating into a bigger system. Also, it's about logging of what's happening, because if we don't have logs, we don't know when unwanted things happen. Sorry, I hesitated because the word with S, starting with S, came to my mouth. You have to read somewhere what happened there and to be able to do the proper corrections. So this is the second area it's about changing and adding the code that we get from data scientists. It's about testing that code into not exactly the final one, production environment, but into a production-like environment from all points of view. And in the last step, it's about deploying that model into production, into an online system. And for sure, here are persons that do deployment into a live online system that has SLAs related to shutting down the system or breaking the functionalities, and know that what it means to do that deployment. After that, because again the perspective is not complete, comes the third area. What's the third area about? Well, it's about seeing how the model performs in real life. Because our experience showed, still shows, probably will show, that conclusions here are not entirely right when applied here into real life. So this is the block that's trying to see how is the model performing. And there are reports there that are analyzed, and the results are fed back into the first area. And this is how the life cycle of model development is closed. I just wanted to see what comes next. This is theory. And with this part of theory being said, I guess we can switch to two of our implementations and talk real exact facts about real models that are working right now into our company. All-weather model, AW model. What about that acronym, AW? It's all-weather. Well, as you can see in the picture here, it's about horse racing. We are a betting company. All-weather means that those horses run on tracks that are covered with some synthetic material, so they can run. Doesn't matter if outside is raining or whatever, all weather. Okay, horse run on all weather. Which is the purpose of this modeling? The purpose of this modeling is to predict the odds for the horses that will run its future tomorrow. I don't know if you know about betting. I myself knew very little about betting. Now I know from theoretical point of view a lot, only in theory. But let me try to make it clear what the all-weather model works for. We take, of course, the theoretical, hypothetical situation of having an event of flipping the coin. Basically, mathematically, which is the probability of having tail or head? It's 50-50, obviously. Okay, So let's assume now that a betting company put this event on the table for the clients and say, okay, you can bet. What will it be? Head or tail? And when a betting company do that, they offer some winning odds. Let's assume that we are offering a 2-to-1. That means that if a client of us give us one cash in, €1, and bets on tail, doesn't matter. And another client give us €1 and bets on head. We got €2. And we offer a 2-to-1. That means that whatever happens with that coin, head or tail, we get €2 and pay €2, which is the profit. 0. This is the reason why a process which is called demargination comes into place, which is a very simple process of saying, I don't give you 2-to-1, but I give you 190. So, as you can see there, it's a easy math, I guess. This is how we get a €0.1 gross profit from this kind of event. Seems very easy. And it is. This one, it is easy. Which is the challenge? Which are the challenges, in fact? First challenge is that we have to know one day ahead which is the mathematical probability for each horse in the race. Okay, which is the mathematical probability? Because, as you can see here, when we said 190-to-1 odds, we started from 2-to-1 because we knew that mathematical probability. But now it's about knowing the probability for the horse that will run tomorrow. Well, this challenge is overcome by saying that the last price immediately before the race is starting is the mathematical probability. Okay, but that price is tomorrow. And we have to offer our clients today the prices. Let's assume that tomorrow for a horse it will be 3-to-1. But it will be tomorrow. We don't know if 3-to-1. So somebody should say something. It's 2-to-1. Okay, what happens? Time passes and the prices tend to go to that 3-to-1. So basically we will align our price during the time until tomorrow when the race starts. But all the bets placed, imagine we talk millions of bets. Millions of bets. Sometimes per hour we have millions of bets. We have a period of time with that not very good odd, 2-to-1. This is where our model, machine learning model, comes into place because it is able to predict which will be tomorrow the, let's say, right price. And we can offer from the very start to our clients the right price, which is right for us. You saw that the imagination process, but also is right, is fair for the client. That was a little theory about how a betting company makes money. This is about how that machine learning model, able to predict the prices of tomorrow, is working right now in our company. Top technology. Just reading titles. For sure, for most of them, for most of you, it is, you know about them. It's about talent, it's an ETL. It's about airflow, it's an orchestration tool. Redshift database. Pod. That is, last in the right, is our low latency relational database. It's Aurora. It's called Aurora on internet. S3, SageMaker, and an API here from an external provider. A lot of technologies. What I didn't say. Input data from here comes at a moment in time. Output data here, delivered here, is needed in at most 1 hour time. Basically, they want it in 20 minutes. We provide it in 15 to 27. This is the time frame from here to here. What happens in this time frame? At about half an hour. We take data from an API provided, the data provided by our external provider, parse it and load it into our Redshift database. From there, another process is doing the checking, the validations, because we don't know what data do we take from here. We take JSONs. So basically, there can be whatever. We take the data, we validate the data. If everything is all right, we unload the data into S3, where it is delivered as available for SageMaker, which is a universe by itself. We will detail it a little later. Here, the predictions are happening, but not only the predictions. Then the results are stored into S3, from where are loaded into our low latency database, and the BI tool provides that data to the persons, I guess they are called traders, which are responsible for deciding the prices, the quota odds that will be placed on the site. I said that inside SageMaker there are happening the predictions, but not only. Why not only? 1,500 over 1,518, it's the exact figure, features are used for the predictions we were talking about. As we extract data from our database, it is not as the model needs. So basically, we had to develop inside SageMaker a custom approach for doing the predictions that includes pre-processing the data and also after predictions, post-processing the data. Everything is in custom code inside SageMaker right now. In fact, it's inside this Docker. We obeyed, we followed 100% the recommendations done by SageMaker documentation about how to structure the data, how to put the data, how to use the resources. So basically what you see here is that we get data from S3, we put data in S3, but we also get parameters from S3. We also store the model in fact, it's an automatic function, but there are the artifacts stored, and together with the artifacts, model artifacts, we also stored the parameters needed both for pre-processing and post-processing mechanism that we implemented. And again, talking about technology, we are using Elastic Container Registry, we are using SageMaker, we are using S3 from Amazon, and inside here it's Python coding. While leaving possible other details for a future discussion, I'll hand over to my colleague to talk us about the second implementation of machine learning.
Thank you. So, we are a betting company. We are happy that our customers put bettings, but we do have to take care of our customers. So the next model that I will talk about is our model, which is called CAP, Customer Activity and Awareness Program. At Paddy Power Betfair, we do want our customers to enjoy their visits on our sites and shops, to stay in control and to only bet what they can afford. So for this, we have robust and wide-ranging policies within responsible gambling and routinely engage with our customers that we think are at risk. So maybe you don't know, but in 2014, our company was the first gambling company to actually have a machine learning model within responsible gambling. So because of that, we are a quite well-respected company from the Gambling Commission perspective, because we have taken proactive steps to address the problems that come with irresponsible gambling. The UK Gambling Commission produces an annual survey where they ask their respondents what is their relationship with the gambling. So here we have some figures from this report in 2017, where we can see that 0.8% of the respondents identify themselves as having an issue with gambling. It is not a very large percentage, but in numbers it certainly is, and we do need to do something about it, and we actually do through our machine learning model and program. As we can see here, using our resources from the second half of 2018, more than 11,000 responsible gambling awareness interactions have been done across Paddy Power retail, and more than 2,000 self-exclusions were done across retail. And maybe you don't know, but we were the first company to actually have a self-exclusion tablet within retail. Okay, so while it is important to identify the right customers at the right time, it is also very important to intervene efficiently, depending on the risk of the customer. So we invest heavily in the analytics and machine learning to do this, and we have what we call an industry-leading responsible gambling predictive model, which is, I'm going to talk about. I'm going to give you some insights in a bit. So here are some key statistics of our predictive model. We use more than 1 million active customers per month, and more than 50,000 customers are being identified for follow-ups, so for taking actions in order to make sure that they gamble responsibly. Okay, so it has been a challenge to identify the patterns that indicate whether a customer has problems with the gambling or will develop problems with gambling, or will have a potential gambling risk in the future. For this, we have two indicators. The first one would be the PGSI scores, which are given by a survey of questions of a customer's relationship with the gambling. And the other one would be the self-exclusions, through which we provide our customers the possibility to take a break from using our products for a given period of time. So using these two leads us to a classification problem, and this problem is solved by having a machine learning model in place. For our machine learning model, we have more than 100 variables in terms of customer info and transactional data, and our target variable is the probability that a customer would develop gambling issues in the future. Combining these two moves us along to the right, where we have our model, and our key output is the probability assigned to each of our customers in terms of would they develop a gambling issue in the future. And having this key value, our responsible gambling operation team is doing a proper level of actions in terms of emails or marketing suppressions and many other proper actions. Okay, so in order to automate the process of getting predictions, we use this data flow. It is automated using Apache Airflow, which is an open source platform for orchestrating and scheduling workflows. So here we also use AWS SageMaker, and in order to do the batch predictions, we use batch predictions because we have large amounts of data. The batch transform job from SageMaker expects the data to be in S3 and streams data back to S3. So that's why we unload our data, which resides in a Redshift database. We unload it to S3, and then predictions are streamed back to S3, from which we upload them back to Redshift database. And from this database, our responsible gambling operations team use it to, as I previously said, do the right actions for each level of score assigned to the customers. We also get logs and email execution status in order to make sure that we provide every day the predictions to our end customers, which is our responsible gambling operations team. Okay, so I've talked about the model, and here is our SageMaker flow. We have two key components here. We have the training part, we have the prediction part. The link between these two is the model artifacts. This is a standard SageMaker approach. But in order to be able to put our custom approach into it, we have used the latest SageMaker recommendations, which is using the custom script mode. With this approach, we wrote our own script for the training and for the prediction. We embedded it in the model, and from this, our model code executes in a SageMaker container. So it is like a machine where we also have a requirements file, and SageMaker recognizes it and installs all the necessary libraries that are needed to execute our code. Okay, so we also have training data, prediction data stored in S3, model artifacts also in S3, and then predictions at the path we provide to stream them back. Okay, so this being said, these are our implementations, two of our implementations, and we are going to move on and talk about our future plans and our future use cases.
Yeah. Well, there is a documentary on Discovery Channel that has as a subject artificial intelligence. And I've seen there that in China there is a chatbot, and it is used, it is in practice, not in laboratory, that a lot of adolescents, and in China a lot of adolescents means a lot, are using that chatbot on their server phones as a closest friend, their closest friend. They talk with the chatbot. They say what they are eating. They say what they discuss with, I don't know, what teacher at school. They put questions What should I do with the teacher, whatever? And the chatbot answers, pertinent answers, what I've heard. I've seen that in USA, there is a chatbot and there is a screen, TV screen with a pretty human but robotic lady, which is talking, the chatbot is talking, with the soldiers that suffered injuries as a therapist. Again, a dialogue between the soldier and that robot with very coherent and pertinent answers. And more than that, the study proved that those soldiers enjoyed much more having that therapy sessions with a robot, not with a physical personal doctor. In Japan, they were working with an android, in fact, trying to teach morals to that android. Morals means what's good and what's not good in terms of society's subjectiveness. For me, it's unimaginable, but Japanese are doing that because they want to integrate those androids into human society, and without morals, it seems to be impossible. Okay, what I've got from that documentary. I've got that China is far away in artificial intelligence. I've got that USA is far away in artificial intelligence. I got that even Japan is far away. But what does that mean for us? Us, again, means Cluj, data and analytics from Paddy Power Betfair into Flutter. That means for us that we have a lot of work on a path that is already drawn. So yes, we can do this journey to continue machine learning, artificial intelligence into our company. Necessary steps for that. Maturing and fine-tuning our current capabilities. As you've already noticed, we are a significant consumer of AWS services. We are so significant that we became, are and will be, strategic partner of AWS in terms of having, now and in the future, common projects to work together on them. Why? Because tens of functionalities that now exist in AWS were developed at our request with us. Because thousands of, I forgot the word, and I don't want to use bugs, but you understand, you get the picture, were solved because we saw them, we reported them, and we helped solving them. This approach with Amazon will continue. Still, we are not focused only on Amazon. We assess other technologies which are not necessarily Amazon, could be hosted by Amazon, but for sure they are hosted in cloud. Why do we do that? Because we are trying continuously to follow our clients' needs, our clients' requests that are, of course, dynamic. I can give you, related to ML, a small example. It's about feature store. Already, we are big in automation. As you've seen from those ML implementations, it is full of automation. No human intervenes in the process from the start to the end. Just read the logs if somebody wants to do that. We want to continue that because there are and areas that need automation tends to born each day new areas of that needs automation. And because we are talking about dynamics and about new, I'll let Anca say something about other use cases.
Okay, so beyond this, we also have a bunch of new advanced analytics use cases which are currently in progress or already implemented, which is, as you may have seen, recommendations. We have recommendations for our gamblers. We have personalization efforts in order to personalize the gambling experience. And we also have models to predict the customer behaviors on which business decisions are made. And beyond business, we are starting to use ML in order to be proactive for our platforms, to take proactive steps for our platform stability. And for this, we have some ML models that predict resource consumption or platform outages, which will bring real value to our data team. With this being said, we leave room for questions, if there are some.
Yeah, and thank you for your attention.
And thanks for everyone's attention. Thank you.
If there are any questions, we try to answer. Yeah.
I think there is a regulation in place in order for every betting company to have responsible gambling. And this is very important for every betting company to take care of the customers. I think it's also a business requirement, so we are data engineers.
I guess it's a mix. We are not working in that area, but we hear what our colleagues are discussing, and it's a mix. For sure, there are regulations that stipulate something in that area, but also, for sure, there are internal decisions that goes into that direction because this is a very big company. Honestly, I know some companies, and I can say from personal experience that this is a very big one. Big companies want to have clients that rely on that company, want to have clients not tomorrow and today, but also from, I don't know, years from now. So when you take this approach, yes, you get very interested in that subject. And yes, you try to solve it. And some of companies succeed. We, for example. Yes.
Yeah. So as I've said, we have 100 plus variables that intervene in this process, and yeah, there are some characteristics of the gambler which are related to its gambling behavior. Yes, totally. Yeah. Exactly. Yeah. No. As far as I know, no correlations are being done. Does this answer your question? Okay. Thanks.
Yes.
Can you please say it louder? Yeah. I do not have this information right now because the model is being built out by our data science team. As I said, we just engineer the whole process. But we can take this offline and maybe have a chat in order to better understand what is your question. Okay? Thanks.
Yeah. $1,580. Yes. And if you are interested, I can say that it's only for a subset of horse racing. As I've said, it's all-weather racing. And in fact, it's not on all circuits of all-weather, but only on a part of them. Immense work. Well, it's a neural network there. So basically, it works like feeding the data to the neural network input, and neural network is doing the job according to those hypertuning parameters. Yes.
Yes.
Please, could you repeat a little louder the question? Yes. Yeah, we can provide some details. It's an ongoing project, and right now what we have is related to our Redshift database. From CloudWatch, we take relevant data, and that relevant data again in S3, and from S3 it's taken by, and Anca could say more, the machine learning process in order to get information related to how will Redshift be loaded in, I don't know, half hour from now, 2 hours from now. I guess that's all. And there are two things that we are watching.
So we have two models. One is for predicting the load, and the other one for predicting some inside metrics. So the approach here is the same as we used in the other models. We use our custom script where we write our code, and we make predictions for different periods of time ahead. We use time series data, if that's relevant. Is that okay? Thanks. Any more?
Well, right now there are no more questions, with a little note that we will still be here for at least half an hour. So if other questions could occur, we are outside. Thank you. We thank you very much for your attention.
Thank you.